video, we are going to learn about del operator and gradient. So what is del operator? So del operator is the operator that is written in an upside-down triangle. It is used to transform a scalar field into the ascendant of the negative of the gradient of that field. When applied to a function defined in a one-dimensional domain, it denotes its derivative as defined in calculus. When applied to a field, it may denote the gradient of a scalar field. Del is not a specific operator, but rather a convenient mathematical notation for those three operators that makes many equations easier to write and remember. And what is gradient? Gradient is closely related to derivative, but it is not itself a derivative. It can also be interpreted as a direction and rate of fastest increased. Here are the formulas that we are going to use in solving our problem. In our problem number 1, so if the scalar function of x, y, and z is equal to 3x squared, y minus y cubed z squared, so find the gradient of differential scalar field at the point 1, negative 2, and 1. So this one is x, y, and z. So now we are going to find the partial derivative of the function. So the gradient of differential scalar field is equals to partial derivative with respect to x times the unit vector in the I direction plus partial derivative with respect to y j plus to z k. So multiply to the function 3x squared y minus y cubed z squared. So now we are going to expand the function. Now we are going to find the derivatives with respect to x, y, and z. So in x, so let me see. How about in y? And in z, and now let us change the x, y, z to its value, which is 0.1, negative 2, and negative 1. So gradient of differential scalar field is equal to negative 12i minus 9j minus 16k. Now in our problem number 2, so find a unit normal to the x squared y plus 2xz is equal to 4 at the point 2, negative 2, and 3. So now we are going to find the partial derivative of the function. So gradient of differential scalar field is equals to partial derivative with respect to x times with the unit vector in the I direction plus partial derivative with respect to y times with the unit direction of in terms of j plus partial derivative with respect to z times the unit vector of the k direction times the function x squared y plus 2xz. Now we are going to expand the equation. Now we are going to find the derivatives of x, y, and z. So in terms of x, in terms of y, in terms of z, next we are going to change the x, y, z to its value, which is the point 2, -2, and 3, where x is equals to 2, y is equals to -2, and z is equals to 3. After performing the operation, so we arrive in this equation. So, gradient of scalar field is equals to -2i plus 4j plus 4k. So after performing the operation, we have arrived in our answer, which is the gradient of differential scalar field is equals to 1/3 I plus 2/3 J plus 2/3 K. So that's it. So this is our answer. So that's it. I hope that you've learned a thing or two in our video. So thank you and have a good day.